First of all, I'm not sure how many of you are familiar with what OpenSIPS is, so I'll just give you a couple of insights about what OpenSIPS is. More or less, OpenSIPS is a multi-purpose SIP server, which can do whatever SIP heavy lifting for you. Heavy lifting in terms of functionalities, so we are able to do any class 4 and almost anything class 5 signaling related features, and also when it comes to the throughput. We had in the very beginning of this week, on Tuesday, we had an OpenSIPS summit, an event about where we talked about latest news, and we explore real case usage for OpenSIPS, what is going on lately, what are the future plans, and so on. So we are built around a very dynamic community. And we talked about, I said throughput, so just to give you an idea about what can OpenSIPS do for you. One of our important things is to be a carrier-grade solution. So that means to be able to handle large amount of traffic in a very fast and reliable way. And everything reduces to being able to scale with the hardware you are using for your service. And with the latest 1.11 release, according to our tests, we are able to scale all the way up to 60,000 calls per second on an IBM server to handle 5 million simultaneous calls on a single machine. So once again, I'm talking about one OpenSIPS instance with a single machine, and to be able to handle around 500,000 TCP connections for end users. So we are focusing also in this scalability side, but also on the service side. So we will talk today more about the services. What kind of extra services can OpenSIPS deliver in combination with your Asterisk service? So, okay. Nice. LibreOffice crashes. Sometimes happens. That's a problem with the software today. Okay, let me restart. Yeah. So that's, let's say, more or less a typical Asterisk deployment, where you have to deal on the inbound side with your end users, with the endpoints, and also you have to interface on the outbound side with carriers. So let's see exactly what OpenSIPS can do for you in such a typical scenario. So first, by placing in front of your OpenSIPS and in front of your Asterisk and OpenSIPS, you can first protect your Asterisk service, so take care of security. You can take care about scaling. You can take care of transport things like using TLS and stuff like that. And also you can create a single point of contact for the endpoints or for the carriers, so to hide your Asterisk. Once you have these boxes, which actually can be a single one, for the inbound and outbound traffic, then OpenSIPS can transparently for Asterisk take care of a lot of additional services that will become available to first users and second for you as an operator, completely independent to the Asterisk. So basically you don't have to change anything on the Asterisk side, just put the boxes in front, and then boom, you have maybe 100% more features to offer with your service. Step number 2, once you have such, we typically call it the OpenSIPS sandwich, inbound, outbound, Asterisk in the middle. So once you have something like that, then instead of a single box Asterisk, you can start growing. You can have an actually pool of Asterisk boxes over there behind, and OpenSIPS will take care of high availability, load balancing, and whatever. So basically managing the Asterisk cluster. And whatever you do in the Asterisk pool in terms of changing will be completely transparent for your endpoints and for the carriers, because the front end will be all the time the same. What you do in the backyard will not be visible anymore. So let's try to go from inbound and outbound to the outbound side and see exactly what kind of things you can do with OpenSIPS. So starting with the inbound, looking at the lower levels, like the transport level, you can enable TLS and TCP to UDP conversions. So basically, you can have TLS TCP connections from end users, TLS with multiple domains, multiple certificates. So quite a dynamic setup. Everything finishing into OpenSIPS, and OpenSIPS doing the conversion to UDP further to Asterisk. In a similar way, you can address the WebRTC side. The advantage, because also Asterisk natively supports WebRTC, but the idea is to keep it as to keep all these kind of protocol-related tasks as far away as possible from the core network. So that's something that you need to address somewhere at the edge of the network. The idea is in the core network to actually focus on the service itself and not to, let's say, transport-related things like what transport I'm using. So in the same idea, OpenSIPS can take care in a very scalable way of the NAT traversal. So you get rid of all these problems from the Asterisk and you move them into the border side with OpenSIPS. Then it's about the security part. So OpenSIPS can do on the inbound, so towards your endpoints, your denial of service, so detection of denial of service attacks, and prevention, basically detecting floods, blocking, automatically doing blocking for the traffic, so protecting the core network, the Asterisk boxes. It can do fraud detection for the endpoints. It's a typical, I wouldn't say maybe typical, that's not the right word. It's unfortunately, it's a very popular situation where endpoints are hijacked, with authentication or whatever, like, and then they are simply used to push calls into your platform. So with the fraud detection mechanism, based on profiles, on dialing patterns, OpenSIPS can detect when, let's say, an account was hijacked by an attacker and used, to push fraud calls. And this detection, it's as I said, it's based on dialing patterns, like what are the typical destination the user calls, what are the working hours for the users, what's the calling rate, how many simultaneous calls, and so on. So you create a profile describing the dialing behavior of the user, and OpenSIPS will continuously monitor the calling for each account, and when it sees something not matching the pattern, the profile, it will automatically report as a possible fraud. So you can detect and then take actions in blocking. Also, when it comes to the security, OpenSIPS can take care of detecting and handling call injections, different kind of attacks based on the record route or loose route mechanisms with fake contacts headers and so on. So keeping the state of the calls, it figures out whatever doesn't fit into a call. So automatically, in a more enhanced way, you put all these security filters in front of your core service. Then, looking at the SIP traffic itself, we can do filtering based on SIP methods, on user agent names. Everybody knows about SIP vicious and other scanners or that you want to block as soon as possible and not to go into your core network. So that's part of the filtering. traffic validation. So whatever gets to your Asterisk box needs to be a consistent SIP traffic, otherwise will be discarded. Really important is the traffic shaping in terms of controlling the bandwidth. You can allocate different amount of bandwidth to, let's say, each account, each users. So you can do this directly into OpenSIPS or call a number of parallel calls to limit these once again per user, and in a similar way, calls per second. So you can control the traffic that you get into your platform in a per user manner in such a way that you protect yourself, or it may be a matter of, let's say, billing or selling different kind of packages to your users with different kind of capabilities. And because we have to keep talking about the endpoints, OpenSIPS can do on the authentication part quite many things. So you can do starting from let's say the simple IP authentication for the SIP trunks. So you can have something like that directly into OpenSIPS to manage the SIP trunks in there. Also, you can do the digest authentication with different kind of backends with SQL, NoSQL, LDAP, or Radius, or whatever. So you can outsource this into OpenSIPS. The idea is you have a lot of flexibility in performing authentication, caching authentication data, so to make it faster and so on in OpenSIPS, that it's more efficient to have it in OpenSIPS in front of Asterisk. So let Asterisk to do the, let's say, the PBX part. And if we are moving a bit higher in the stack, we have services that you can enable with OpenSIPS. You can completely, once again, transparent for Asterisk. You can enable SIP simple by having the OpenSIPS in front. So you can have, starting from typical SIP presence, dialog info, or message weighted indication, bridge line, shared line appearance, bridge line, and so on, XCAP, all the features from the presence ecosystem. You can have them automatically available for your users. Also, instant messaging, end-to-end, or chat rooms with IRC-like behavior. So you have all these packed and ready to be offered to the end users. Also, we can do a lot of third-party integration via presence, like offering different kind of information. At the end, presence, it's a generic way of sharing information with the SIP. And it's not necessary to be only SIP information like I'm online, offline, and so on. So presence in SIP is more than that. And the idea is you can collect information from different kind of third parties, so outside OpenSIPS, and use OpenSIPS in order to inject this kind of information into the SIP side. For example, you can publish your geolocation information, you can publish announcements, status of servers, or whatever. Looking at the, let's say, caller and callee services, for the inbound part, you can have OpenSIPS to manage DIDs from the DID providers. So you can map them onto the accounts to recognize, filter, whatever. So you can you have a really flexible way in doing the management for the incoming DIDs. You can do CNAME lookups to external providers. So again, directly into OpenSIPS. OpenSIPS can behave as a mid registrar. So in that case, you can achieve parallel registration or parallel ringing for your subscribers. You can create even hunting groups, serial hunting groups, parallel hunting groups, and so on. So once you configure the OpenSIPS as a mid-register, then automatically you have access to such services. One of the most important feature, which is available in OpenSIPS 1.11, is the inbound call center. Basically, we can do call queuing in OpenSIPS at the signaling level. So once again, it's a carrier grade kind of a queue, and the system supports the definition of multiple queues. We do have multiple agents, group of agents with skills. You can have quite a richful set of statistics and reports. So it's a quite complex engine. Everything in the call center part in OpenSIPS is based on the back-to-back engine in OpenSIPS, because as I said, OpenSIPS acts as a class 4 and class 5 switch in the same time. So you can have we have the back-to-back actually controlling the call distribution, like monitoring the agents, which agents are free or not, then knowing exactly what's the priority of the calls in the queue, distributing the calls to the queue, and so on. And the beauty of this is combining with other features from OpenSIPS. You can front-end the call center with, let's say, with a dynamic routing module in order to, let's say, put multiple DIDs for different kind of calls, for different kind of queues. Like I have a queue for customer support, another one for sales, another one for generic calls, and so on. So you can use different numbers pointing to different queues. Also, you can use, let's say, Asterisk as a front end for an external IVR. So you can choose the queue by using a front end IVR. And I said that this is a carrier grade call center, meaning that you can support thousands of agents in the same time on a single box. You can have hundreds of thousands of concurrent calls or calls in the queue. So it's about a completely different size, because we all know that Asterisk can do also call queuing, but once again, here is about carrier grade. Yes?
If you want to play music on hold or do pop-up and things like that, you have to
Yes, we do. As I said, we do only the signaling, but when it comes to playing, let's say, announcements, welcome messages, or whatever, or the queuing message, the music on hold, yes, in that case, you rely on an Asterisk or on an external media server, which can be like Asterisk. But the beauty is you have a single engine, call center engine, and you can have a pool of media servers providing the RTP injection. You know, so you don't have to scale separately. I mean, in the same time, both the signaling and the media. And this works really well in geo-distributed scenarios, like having agents in different areas, but still a single queuing. Because once again, queuing means signaling. Signaling, it's not, let's say, affected by you know, by location, by differences in locations. And you can distribute the media servers for injecting the RTP in such a way that it's all the time closer to agents. So that's, let's say, a typical deployment of a call center by simply using Asterisk, and by putting then an OpenSIPS in front and doing the call queuing into OpenSIPS, you can get to something like that. Once again, we are talking about a single box, not necessarily about building clusters. So it's the capability of a single OpenSIPS instance. That's a typical setup for the call center when you have where you have gateways with the incoming calls from the PSTN side, for example, with calling to different DIDs. DIDs are landing and the calls are landing in OpenSIPS. OpenSIPS can have an IVR in front to detect the call, detect the queue, sorry, depending on your setup, and then using an external media server for doing the RTP playback. But OpenSIPS is the one responsible for managing the agents, for keeping the calls in the queue, and then distributing the calls to the agents. Okay, so now moving to the middle side basically meaning having OpenSIPS managing the Asterisk pool of servers. We have the load balancing, yes? This one? Or? Recording the calls? Well, we can do call recording directly from OpenSIPS. That's the easy one. Because even OpenSIPS itself doesn't do media, so it's just signaling. There are tools like media enablers, like RTP proxy, for example, which is used for NAT reversal, but at the same time you can do call recording with it. So we can by simply using OpenSIPS with, for example, RTP proxy, you can do recording for all the calls. Okay. So managing the Asterisk pool, OpenSIPS can provide a different kind of load balancing techniques. Load balancing based on the actual load as calls, simply dispatching, and so on. But the idea is you can do a load balancing which is in a SIP-wise balancing, so it's not a simple dummy distribution of the calls, because you have to be really careful when it comes to call transfer. You know, you have, when you do, for example, an unattended call transfer, you have to be sure that both calls, the original call and the transfer call, needs to land exactly on the same Asterisk box, otherwise Asterisk will not be able to do the transfer itself. So you don't have to implement a simple dummy balancing, but you need to take care also about some particularities of, let's say, how SIP works. You can have monitoring tools on the Asterisk boxes to get information about the load and to update the balancing algorithm in OpenSIPS in real time. So everything is feedback based, so quite dynamic. And aside the load balancing, OpenSIPS can do also the ensures the high availability for the Asterisk cloud. So it can detect in real time the faulty Asterisk servers. So if one goes down or whatever happens, then it will figure it out automatically and reroute calls to the remaining boxes. You have mechanisms for auto re-enabling based on probing. So OpenSIPS can probe at SIP signaling level to see when the Asterisk boxes are back online and start using them automatically at that point. And by using the provisioning interface in OpenSIPS, you can manage in a dynamic way the pool of Asterisk servers, like disabling, adding, removing servers, Asterisk servers in the pool, basically so completely transparent for your end users or for the carriers. So everything happens only in your backyard and nobody sees anything about it. And the last part, we have the outbound side. So basically the outbound side means calling to the carrier, so the relation between your Asterisk service and the carriers. And we have services which are more like carrier-oriented. You can do in OpenSIPS the topology hiding if you want to hide whatever topology you have in your core network. And in some cases, maybe carriers do require media pinning. So to have the same source for the RTP as for the signaling. So we can do that also in OpenSIPS. On the outbound side, you can do the LNP dipping, so for the number portability, to be sure that you route to the proper carrier. So this part can be handled by OpenSIPS. You may have support for SIP session timer in order to detect, we call them zombie calls, so calls which are interrupted, signaling from signal perspective, so to avoid problems in billing in your relation with the carrier. And where if we are talking about routing to the PSTN side, we have typical prefix-based routing. So at the end, the idea is OpenSIPS can offer so many routing algorithms to the PSTN. So starting from the prefix-based routing, you can do least cost routing. And least cost routing, I mean, in a really scalable way, because you can, we have actually a situation where you have maybe tens of millions of routing rules, so for international destinations, and thousands of gateways, you know, depending on how many carriers you have and so on. So that's a lot of information that OpenSIPS can handle in a really easy way. Not to mention that you manage it in a single point, which is in OpenSIPS, so you can play around with the Asterisk servers, like scaling, without having to update your carriers with all the IPs of your Asterisk, or the other way around, to update each Asterisk whenever there is a change into the, let's say, in the routing information. So you move all this in a single point, which is your outbound OpenSIPS. We can do quality routing. So basically, when you route to the PSTN, OpenSIPS can learn from the signaling level the quality of the call, so measuring what's the post-dialing delay, what's the rate of establishing calls, and so on, so all the typical parameters. And then you can do routing based on these parameters, so all the time to choose the best quality gateway, you know, instead of simply doing kind of a static routing. So you can also have the capacity-based routing, where for each gateway you can define what's the maximum number of concurrent calls, what are the calls per second, and so on. So you can do whatever algorithm you can use, maybe all of them in the same time, depending on your setup. And talking about gateway or carriers as an endpoint, OpenSIPS can take care of the high availability for these endpoints to detect when a gateway is down and to do failover to another one. Can monitor the status of the gateway to see which ones are online or which ones are down. So more or less that was the topic for today, how to enable additional services which are not typically present in Asterisk, so how to enable them for your Asterisk-based servers. It's much more to talk about. I didn't want, for example, to go into really complex billing things, combined with call transfer, and billing for inbound and outbound, billing carriers, billing users, and so on, because that's a completely different kind of a beast. But just to be aware that you can easily solve also such kind of problems by using by having OpenSIPS sandwich with Asterisk, because that's the way, as I said, we call it this kind of a combination. So thank you. If you have questions.
Please raise your hand if you have a question, and I'll come with a microphone.
Actually, two questions. First
Okay.
one, what kind of hardware configuration? And secondly, apart from Asterisk at the back end, what other back end can you use this for?
So what kind of a hardware? Well, from OpenSIPS, it's designed in a way to be very light resource user. So you don't need any kind of a special hardware, like capacity. Unless you don't want to do like crazy things, like to put like a couple of millions of parallel calls and so on. In that case, of course, you'll need maybe like something like 24 cores, processors, and memory, and so on. But let's say it's not out of the ordinary, considering the scale of the things you want to do. And the second question was about the... backend in terms of like databases or what? Well, here actually the problem is the other way around, because we start from the Asterisk and we try to, if I can say so, solve a problem for the asterisk, like how to enable. So, yeah, I mean, of course, let's say you can extrapolate and go with the same kind of a recipe for platforms which are based on other kind of SIP servers, you know, or PBX, CPBX is not necessarily asterisk, but the idea was to show here the direct relation with asterisk, considering what are the capabilities of asterisk right now.
That was a great question. I have another one over here.
What do you use to monitor the call state and the call load on the Asterisk servers?
Well, we can do the monitoring of the calls directly from OpenSIPS. We know exactly how many calls. So we are dialog stateful. So we know exactly how many calls are at each moment on each asterisk box, considering that we dispatch the calls to asterisk. So all the time on one end of the call it's in OpenSIPS. We can simply count how many we have to each asterisk box. So based on that, we can calculate a load for each box. That's the typical approach if you think about like media-oriented services like conferences or voicemails, which are more difficult to count. I mean, it's not like simply counting calls. In that case, you can have, let's say, simple monitoring tools to, let's say, to get the CPU load, memory usage, whatever on the box, and simply push information back to OpenSIPS like, okay, be aware this box is overloaded, don't send anything more to it. But this, let's say, it's a matter of integration.
Any further questions?
Back to the BLF that we talked about a little bit. So for example, if we have an asterisk environment and there's a phone that has a button that's the representative of a time condition. So for example, on night mode, we assign that button to be red, and the day mode it's green. And it works with asterisk, but if this phone now registers to an OpenSIPS, how can we actually extract that information from asterisk and do the button manipulation in terms of the color of that button to show if we're in the day mode or the night mode?
Well, usually this kind of a mapping, you have to do it, part of it on the phone, right? So to know exactly the phone, the indication from that button, and what action to trigger inside the phone. But then on the server side, whatever, from the presence perspective, so whatever, let's say, Asterisk can do, also OpenSIPS can do, because we are a fully flavored presence server. So we can aggregate typical presence information, including the BLF or SLA or whatever, or dialog info and so on. So these are like standards when it comes to presence. So basically, it's all the time, it's between the presence agent, which can be either Asterisk, either OpenSIPS, and the device. So you don't need all three parties to be involved somehow in having this working. Yeah. Probably it's a matter of configuration. Maybe you will need to do like mid-registration also into OpenSIPS for the BLF part. I have to think about, because there are so many extensions, and sometimes I don't remember exactly which one is doing what. You know? But we can take this discussion if you'll, yeah.
Thanks for all the great questions, and thank you, Bogdan, for the excellent
Thank you,
presentation. Let's all give him a hand.